about guarantees. So when you design something, you are saying, okay, my design is robust in any odd conditions, right? So finally, every design should go through a peer or design authority review to validate scalability, security, and cost, because those all are important things, right? Remember, what's not documented doesn't exist. A well documented design ensures anyone can understand, maintain, and extend your integration in the future. So you have to make sure that your design uh, is understandable by non-technical and technical people. So normally what happens is high level design is much more for, or put it this way, the high level design document is easy to understand by non-technical people. When you go into low level design document, it's a little bit difficult. They can understand it, but still they're a little bit difficult for non-technical people to understand in depth. So put it this way. All right, let's move on to the next one. Now, step 5 is to build the integration components. Now, this is where design meets execution. Every developers should follow approved standards. So because we have done this thing in step 0, so they have proper guide. They know what to do, how to name, how to create, how to create repository or sub repository. Just they know all those things. How to check in and who will, pull the request, who will approve it. So all those things are very clear. So we need to have a consistent naming, reusable code, and secure practices. Use Azure native services like logic apps for orchestration, functions for custom logic, service bus or event grid for messaging, and API management as the gateway. This is a part of integration anyway. Always reuse existing components. When possible, connectors, templates, or policies, so you don't reinvent the wheel, and maintain architectural consistency. So make sure that we have all of those things in place, and we need to have a put it this way, we need to have a mechanism to search existing components. So what I found is in many organizations, and it's my experience with the working with them, so they have components, but nobody knows they are there. So what I'm saying is there need to be have a kind of a repository, and there need to be a kind of a mechanism to search them. So to find out about those things. So that if you do not know, then it's very difficult. And it's important to mention these references in design documents so developers know where to find them. Implement robust error handling and retries and correlation IDs so issues can be traced end to end. So when we are doing development, we need to make sure about observability. So we know that if anything goes wrong, we can easily trace them, and it's effective error handling. So we need to remember that we should not our services should not make error exception disappear. It should log. So we need to think about how effectively we can do those things. So in before development, it is also good idea to create common mechanisms that can be used by developers. For example, how to handle exceptions in APIM, how to handle exceptions in logic apps, how to handle exceptions in function apps. So we have some sort of mechanisms for logging, error handling, and managing if it's transactional, how to manage transaction. So we have proper documentation. That's a development part. So that can go into development guide, not in the design document, but in a development guide, that we have all the mechanisms that can be used in development are in our development design guide or development guide. Now, moving on, we also need to think about security because it's not optional. We need to think about using managed identity instead of secrets, store credentials in key vault, and follow the principles of least privilege, so or zero trust. I'm sure you know those things, so just make sure that do not ignore those things as part of this development cycle. Finally, integrate your work into CI/CD pipeline, so builds, test, and deployment happen automatically and predictably. So we should not we need to make sure that our code being checked in, and when we check in, it should verify the quality of the code. Also look, also look for any issues, potential issues in the code, and by mistake some secrets are there that need to be identified and flagged. Step 5 is about discipline of in execution. Build integration that are not only functional but also resilient, and secure and repeatable. Right. So that's about step 5. It's a very important step. Let's move on to step number 6. So step 6 is test and validate end to end. So we need to do unit testing, of course, and we need to do all sort of testing before we actually push our code into production. So in step 6, we start small. We test each component called unit testing, right? Your logic apps, functions, function APIs, and service bus topics. We test them in isolation, right? So individually. So we might need to use some proxy, some mock to test our services, but we need to make sure that we have tested all those things. Do not push code into test without doing proper testing in our development. And I have seen this happening in past. We should not push our code into test without testing, without properly verifying unit testing, right? So once they pass, move to end-to-end business scenarios, and that mirror real transaction. So we would do unit testing, and we do kind of a end-to-end business scenario testing. So we run one process and see everything is working. Don't stop at functional testing. Include performance, security, and resilience, and all those testing we need to think about. So make sure we make sure retry circuit breakers and dead letter handling behave as is expected. So we can like for example we have resilience. For resilience, we have circuit breaker in our in APIM, right? So implementation is not enough. We need to make sure that that implementation is working, right? So we have to make sure that our retries works. We need to make sure our dead letter queue handling is behaving as we expect it. If some systems aren't available yet, like I said earlier, we can mock services and stubs, right? So integration can continue in parallel. So we should not stop for other services to be ready. We can mock them. Always perform data reconciliation. Confirm that what leaves the source arrives at the target intact and complete. So do not, when you test any application, make sure you do not just type 1 2 3 and see everything's working or not. So what I'm saying is do a proper testing. Make sure that when you enter data at the source, you have some sensible data. And if you need to connect with data team, you must connect with data team. Ask them to provide you some sensible data, sanitized data. There should not be any customers email and all those things. So make sure that you have sensitized data, and use that data for testing purpose. All right. So once we have done all of those things, we have automated CI/CD pipeline, and with quality gates. So basically, to catch any issues, then it moves into next level is after testing done. So what I'm saying is we have done testing in development. It moved into testing into test environment quality, and from there now once it's done, then it move into UAT environment, and there the sign off happens. All right. So that's the last gate before it goes into production. So when the business user is happy what we have done so far, they will sign off, and then basically it's a confidence for the next level. All right. So step 6 is about confidence, verifying that your design or code and process, what we have done so far, all come together and seamlessly can we go into production without any problem. All right. So let's move on to the step number 7. Now, once we have those things, we need to make sure that we deploy and monitor those services. Now, when I say deploy and monitor at step 7, it does not mean that we start thinking about monitoring or observability now. What I'm saying is this is a step we need to consider, but we have to start thinking about these things way early stage, right? So from step 1 or step 2, we start thinking about these things. Begin with fully automated CI/CD pipeline. So every deployment should go through approvals, version control, and rollback options, right? So we need to, when we deploy anything in production, we should be able to roll back easily without any problem. So we need to think about how to set up those things uh, in order to we shouldn't have any problem. If something goes wrong in the production, we should be easily roll back everything, including the configuration of the systems, right? So manual deployments always introduce some risk, so we should not go for manual uh, deployment. I know some people are scared of this thing, so I have seen people avoid doing automated deployment, but I think it's a one time fear. So once you have done a couple of times, then you understand the fear disappears and you will do automated you know uh, deployment. All right. So maintain strict environment parity between dev, test, UAT, and production. Don't mix up these things. What works in lower environments should behave identically in production. No surprises, right? So we I have seen this thing many times. People say, "Oh, it's working in my development environment," but some reasons doesn't work in test. So there must be something wrong with the test environment, rather than looking into your own code or your own system. Something's wrong with development in the development. Anyway, so that's my experience because I was a developer as well. So tend to happen. Uh, use When we deploy anything, we must use infrastructure as code. I mean, we can use Bicep or Terraform to deploy logic apps, service bus, function apps, and anything on any service you have. You must use Bicep or Terraform. Do not do manually. All right. So it is important. Just do with Bicep. So make a habit when you in development start writing Bicep or Terraform at that level, and do everything through these scripting. These infrastructure as code rather than doing manually. All right, this is very important, right? Just do not forget that. So this ensures every integration is reproducible and compliant. Okay, let's move on to next step, which is step number 8: maintain, improve, and scale. So once we have done deployment, now it's about keeping your integration healthy, relevant, and scalable over time, right? So we call it maintain, improve, and scalable or scale. Once an integration is live, the real work begins from there. You must monitor it continuously, not just for errors, but for trends, right? So I'll explain what I mean. So watch latency throughout, throughout throughput. Sorry, watch. Okay, watch latency. Look at the matrices, throughput, retries, and failures to identify any bottleneck before they become an incident. So you will see